Welcome to today's video where we will be uncovering the truth about NAT and how it relates to private and public networks in IPv4. I will unravel what is NAT and its role in private networks and public networks for that to function. So if you ever wondered how your devices communicate online and locally, or maybe thought about what the heck is NAT, then this video is definitely for you. Firstly, let's talk about how we distinguish between IPv4 private and public networks. Private networks are like gated communities. They use private IP addresses that aren't directly reachable from the internet, and these addresses are not routable on the internet either. Private IP addresses are also not unique in any way either. It is possible for you to use the same IP range as your next door neighbor and many other households with these private addresses. An example with a private network is usually the local area network or LAN you have in your home. Private IP addresses are usually only meant to be used within a local area network, such as your home or business LAN. So if you have multiple private networks within a big infrastructure, they can still communicate these multiple independent private LANs that you have created. But there is not any access out to the internet, since you need a public IP address for that. Public IP addresses, on the other hand, are used for public networks, which are open communities. These IP addresses are globally routable and is accessible from the internet. Public IP addresses are also unique compared to private IP addresses. So when you have a public IP address, that is the only one address that is for that. To give you a few examples with public networks, I think the first and most obvious one must be the wide area network or WAN of your ISP. You must have access to an internet service provider to access any provider or public network before any internet traffic can be possible from your side. That is why you pay your ISP for getting access to their public network for you to then have access to browse the internet. Your ISP is also connected to thousands of public networks, which is the internet. So in essence, public networks are whatever you access on the internet. The picture here down with the IPv4 private addresses and the public ranges is what you can see. These are the available addresses that you can use within these ranges of both the private and public. But now I know that I have talked a lot about private networks and public networks, but I have not mentioned once NAT. Fear not, that question will be answered in the next slide ahead. So let's talk about NAT, or Network Address Translation, as it is called. NAT is essentially just a translator, kind of a gatekeeper within your router and firewall. Its job is to translate your private network IP addresses to public IP addresses, and vice versa. That is how multiple households and companies can use the same private IP addresses, because NAT hides away the private IP addresses and uses the public IP addresses to browse the internet. So by using NAT, it's like having a huge amount of private IPv4 addresses for everyone to use as they see fit to build their own private network infrastructure for themselves. This is possible because NAT hides away the private addresses and only uses the public addresses to browse the internet with. So why don't we just use public IP addresses altogether, since they are the ones that we use on to browse the internet? Then there won't be any need for NAT or private IP addresses. The main issue by doing this with IPv4 is it is not possible. IPv4 only has these public addresses available, which in total is this. IPv4 was also never intended for so many people to use the internet when it was originally made, and were not thought of that the internet would become this big as it is today. Think of it this way. Nearly every device nowadays is connected to the internet. This includes your desktop PC, laptop, gaming console, smartphone, IoT devices, and so many more. If all of these were to have a public IP address each, we would quickly run out of public IP addresses. That is why a new solution was needed to stop the exhaustion of public IPv4 addresses. That is why, in the end, NAT and private IPs came to life and was intended to stop the exhaustion of public IPv4 addresses, so we did not end up using all IPv4 public IPs in a blink of an eye. So now let's explore an example as to how NAT can work to enable private IPv4 addresses to communicate with the public internet using public IPv4 addresses. Let's take this example here with Bob, who wants to browse YouTube to watch a video. Let's start with these two blue boxes here. First, Bob will establish communication with his own router on his private network, which is this router. Then this router then checks its routing table to see if it knows any routes to YouTube's website. If not, it'll ask its neighboring routers or its own default gateway, which can be the ISP's router, which is over in the public network. When the route is found, either in its own routing table or other routers' routing table, it will then translate Bob's private IP address to his public IP address, so Bob can get to YouTube on the internet. Secondly, let's go through the two green boxes here. When YouTube has received the traffic from Bob's public IP address, it will then send data back onto this IP address. When this traffic reaches your private network router again, it will then translate the public IP address to the private IP address by using NAT. And that is the simple overview as to how NAT switches between the public and the private IP address when it goes between the two types of networks. So that is about it for now. I know this has been a long video, but I'm very glad that you stayed here to the end to learn about this topic. If you don't mind, I would really appreciate a like and a subscribe if possible, since a video like this takes a lot of time and effort. If there should be any questions as well, feel free to leave them in the comment section below. Have a good day and take care.